back to Heparin. I'm Caroline Porter Thomas. Thank you so much for watching. So a lot of you guys were asking for more math tips, and since we just did a video on the medication heparin, which if you didn't watch, don't worry, I'm going to put the link below. There's something really interesting that involves a lot of math that we get to do as nurses, and it's called a heparin drip. Now the heparin drip, when I first used to get orders for this, it used to scare me to pieces because it's a little bit confusing. So I thought what I could do is just give you an example of what a heparin drip might look like, and in that you'll get a lot of math and just see what it's like to be a nurse. So I hope you guys enjoy this. Okay guys, so what we do is when we have a math question related to heparin, the heparin drip, is we use a process called dimensional analysis. Now, dimensional analysis is, if you've never heard of it, that's fine. I had never heard of it either until I started nursing school. So what I'm going to do is I'm going to put a link below to a video that explains what dimensional analysis is. But basically what dimensional analysis is, it's a way to come to the correct answer out of, there's a lot of different ways to get the answer, but this shows you one way. So what I'm going to do is tell you that we're going to say that our doctor ordered a heparin drip. Now we get a protocol from pharmacy. I printed this out for my reference, but I found a website that has a sample heparin protocol drip. And so what I'm going to do is put the link below and you can see what it's kind of like. But it's basically a weight-based dose because everybody's going to need a different amount of heparin depending on their weight and the way that their body interacts with the medication. So we usually have a standard rate to start out with. At the hospitals that I've seen, it's usually 12 units per kilogram per hour. So the doctor will just write an order for heparin drip, and we get this protocol from pharmacy. So we start with an order of 12 units per kilogram per hour. Whenever we're giving a drip, we need to know one thing, and that one thing is how many milliliters per hour we are going to run the drip at. So what we want is mLs per hour, and that will be our final answer. What we need to do before we start anything is we need to find out our patient's weight. Now let's say our patient weighs 150 pounds. So we have to figure out how many kilograms. So you take 150 divided by 2.2, and that gives you 68.18, which we are going to round to 68. Once you have your patient's weight, then you take the ordered dose, which is right here, 12 units per kilogram per hour, and you take 68 times 12. And you will get 816. So what you do is you take 12 units per kilogram per hour and you multiply that by 68 kilograms and you will get 816 units per kilogram per hour. And this is essentially your ordered dose. So if our ordered is 816 units per kilogram per hour, then, and what we want is mLs per hour, we have to figure out a way to figure that out. So using dimensional analysis, we're going to figure out how many milliliters per hour. Now you always start with your given quantity. Our given quantity here is 816 units over 1 hour. So 816 units over 1 hour. okay? With dimensional analysis, like I said, I'm gonna put a link that describes it below. You're always figuring out a way to eliminate unwanted quantities. Our unwanted quantity here is units, but we do want to know how many hours. So what we're gonna do is we have to figure out what we have on hand. On hand, heparin usually comes in 25,000 units per, it's either 250 or 500 mLs. I've only seen 500, so I'm just going to do 500 mLs. So if you look right here, we have hour and ml. Those are what we want, right? Because we want mLs per hour. But if you notice here, this is 816 units, and this is 225,000 units. We don't want units. So what we can do is eliminate this unwanted quantity. Then, since we're already at the things that we want, which is hour per ml, what we can do is multiply across. So we're going to get some very large numbers, but if we take 816 times 500, we will get this large number of 408,000. So 408,000. And then if we times 1 by 25,000, oh, and sorry, we need to put our units there. And if we take 1 times 25,000, 1 times anything is basically just the same number. And then we're going to carry over the hours. So what we're going to get is 408,000 divided by 25,000 equals 16.32. So equals 16.32. And then we take the mLs per hour, which is what we wanted. And that is our final answer. Now, with a heparin drip, what we do is we have to order the initial PTT. So our initial PTT is usually less than 35 because they're not on any anticoagulant therapy. At the minute or the moment you start this drip, we order another PTT for 6 hours. And this is what we call titrating a drip, which is a word that used to scare me at first, but after a while I got used to it. So I'm going to post the link to the site below, but let's say 6 hours has passed and our PTT is 48. Now, if you look at this right here, 48 is a therapeutic PTT on heparin therapy. So no changes at all would be needed. Let's just say after 6 hours, our PTT, okay, so no changes are needed, sorry, and what you do is you also check it in another 6 hours and make sure it's still therapeutic. Let's say after 6 hours, the PTT result comes back and it is 90, the PTT is 90. What we do is we change that rate and you minus it by 2 units per kilogram per hour. So what we usually do is we usually stop the rate for about 30 minutes. It usually says that in the protocol. I'm not sure if it says that here, but in the hospital we usually have an order to stop the rate for 30 minutes and then to restart it at a different rate. So our rate is no longer going to be 16.32. Our rate is going to change. So we have to start over and figure out what our rate is going to be. So let's do that. So our PTT is 90. So we have to go, and our initial rate was 12. So we have to minus 2, so it's going to be 10. So if you take 10 units, sorry, I'm just going to use a U, per kilogram per hour, and you multiply it by our patient weighed 150 pounds, which in kilograms is 68 kilograms. Then you're going to get those 68 times 10. I know you can do this in your head, but I just like to double check myself because it is a medication drip. So you're going to get 680. So that's basically your ordered dose. So ordered is 680 units per kilogram per hour. And now we can start that whole process again. So what do we want? That's always your first question with dimensional analysis. We want to know how many milliliters per hour we need to run this drip at. So I'm just going to put that here just to remind us. mLs per hour. That is our goal. So what we have on hand is 680 units. So let's do 680 over 1 hour, because that's our ordered dose. That's how many units they need to get in 1 hour. So we're going to times that by our on hand, which is, the only one that I've ever seen for heparin drip is 25,000. So 25,000 units over, and then we put the mLs here. Let's say 500 mLs. So again, why did we put the units here and the units here? Because in dimensional analysis, you eliminate unwanted unwanted quantities, I guess. So we're going to eliminate these. And look right here, this is what we want, hours and mLs per hour. So again, we just multiply this by this and this by this. So 680 times 500 is 340,000. Always really important to make sure you grab whatever it actually is. And we take 1 times 25,000, and that's in hours. So it's going to be 25,000. So 340 divided by 25,000 is 13.6. 13.6 what? mLs, per hour. 13.6 mLs per hour. Okay, let's just do one more. Why not? Let's say that their PTT result comes back and it is 36. So what we need to do is we need to increase the rate by 2 units per kilogram per hour. We also need to give a bolus dose, which I guess since we're here, I can just show you how to do that. But first, let's figure out the newest rate, because the newest rate is what we're already kind of used to doing, and the bolus is going to be easy, okay? So it's 36, so we're going to increase it by 2 units per kilogram per hour. So let's just go off our initial rate, which was 12. So we're going to increase that to 14, adding 2. So we take 14 units per kilogram per hour. And that's our ordered dose. Our patient, he weighs 150 pounds or 68 kilograms. So we multiply that by 68 kilograms. And we get 68 times 14 is 952. So 952 units per kilogram per hour. And that is our ordered dose. Now, what do we want? We always need to know in dimensional analysis what we want. We want milliliters per hour. Okay, so let's get started. So we know our ordered is 952 units over 1 hour. Our need to eliminate makes us have to put our on-hand dose of heparin here, which is 25,000 units over, and then 500 mLs goes here. So we cancel this out. So 952 times 500 is 476,000. And what are we left with? mLs. So 476,000 mLs over, you take 1 hour times 250,000. 1 times 250,000 is just 250,000 equals 19.04. And what do we have here? mLs. And what should I have brought down here? Hours. So we have mLs per hour. mLs per hour. So 19.4 milliliters per hour. Okay. So if you look at this right here, I put the link below, like I said, but it says weight-based heparin nanogram. And if you look here, since our PTT was 36, it says increase the rate by 2 units per kilogram per hour, which we just did. It also says rebolus with 40 international units per kilogram. So what we're going to do is, now this is a little bit simpler. We basically have our ordered 40 units per kilogram. So this question is actually a lot simpler because we don't have to figure out a rate. We're just giving a one-time dose. So if we need 40 units per kilogram, then what is our patient's weight? That's 68 kilograms. So what we do is we just take 40 units times 68 kilograms, and we get 2,720 units per kilogram. Now this number sounds really big and really intimidating, but actually we get a little vial that comes in 5,000 units, and we are able to extract that dose from the vial. And there's also a way with the pumps that you can enter the dose into the pump. But unfortunately, I don't have a pump with me. But if you have to get a bolus dose, then that would be your bolus dose. And don't worry about the word bolus. I know it sounds intimidating, but all that means is IV push. Alright guys, thank you so much for watching. I really hope that you enjoyed that. If you did, please give the video a thumbs up and please subscribe to the channel, and I cannot wait to see you guys soon. Love you. Bye.